All right, welcome to section 3.1, day 2. We're going to do the graphing method again. Just a quick note, this was a homework assignment from yesterday, so if you want to check the odds in the back, ask a neighbor, ask the sub if there's any of these that don't make sense to you. And then once you have everything checked and okay, you can turn it into the basket. I wanted to walk through real quick with you number 11. That one kind of had a twist from the other day. The system 2x minus 2y equals 4. And y minus x equals 6. And so yesterday we solved by graphing, starting with putting them both in y equals form. So real quick, minus 2x is here to cancel that out. So minus 2y equals 4 minus 2x. Divide by negative 2 to both sides. So we get y equals negative 2 plus 1x. The other equation, a little bit easier, just add x to both sides and then you have y alone. Okay, and now to find the solution, we just graph them. All right, and a quick review from yesterday was when you graph, basically you want to plot the two lines, and find where they cross. And wherever they cross, that's your XY answer. This one, however, has kind of a twist to it. If you can see here, these are parallel lines. They've got the same slope. And when you graph, take a look at decimals here. Type them in real quick and graph, and you get two lines that are parallel. All right, and so all that means is the lines are parallel, they never cross, so they don't share any points in common, and that just means there's no solution. All right, so 11 had a trick that basically there is no solution, no XY pair that works for both equations. All right, and I wanted to go over this one because I think it's a good lead in today's lesson. We're going to talk about figuring out when is it no solution, when is it infinite solutions. Those are kind of special cases. Okay, so turn in this assignment in the basket once you're done. In notes, if you want to title a new note page, goal today is to determine when a system has one solution, no solutions, or infinite solutions. All right, so once you have that goal down, write down these three pictures, and then we're going to label some notes beneath them. So pause the video, draw these three graphs quick. First situation is the one solution case, kind of the normal case, what was happening for the most part yesterday. And that'll just be when the two lines cross, wherever they meet is just that XY point. So in the one solution case, you just get one XY coordinate pair for your solutions. Middle case is the first special case called infinite solutions. And this will happen when the two lines lie right on top of each other. In this case, they share a whole bunch of XY points. They have all those points in common. And so there's infinite points where they cross, hence infinite solutions. All right, and the way you'll be able to tell this is when you have the same equation. So if you have the exact same equation, then you know that it's the infinite solutions case. So just as a quick example here, say our system was y equals 2x minus 3 and 2y equals 4x minus 6. Say that was our system. Then if we just took the second one and divided everything by 2, we could say, oh, hey, these are actually the same equation, right? Once we divide the second one by 2, you can see that, hey, these are actually the same equation. And then we don't even really need to graph it at this point. We could just say, well, since they're the same equation, it's going to be infinite solutions. Last case then is what we were talking about in the homework question. That's the no solutions case. Okay, and that happens when you have parallel lines because they don't cross, so they don't have any point in common. And basically in this, you'll have like the same slope, but a different y-intercept. So if you just want to draw an example here, minus 2x plus 5, and let's say you have another one that's minus 2x minus 3 or something like that, then you can see they have the same slope, but different y-intercept points. So they're parallel and they'll never cross. And then you'll know it's no solution. So in theory, again, you don't even really need to graph that one because we know that there's just a pair of parallel lines. So there's no solution. So hopefully you got this down in your notes. All right, so we're just going to do some sample questions with you. And again, if you want to copy this down, and we're just trying to figure out how many solutions it has. The directions in homework and stuff, we'll say without graphing. So if you don't need to graph, don't graph. But there will be some where it will actually make sense to graph. If you have to find the one solution, then I would actually graph it. Okay, so number one. So we're going to do our trick yesterday where we're going to get y alone, because in theory, we're going to be thinking about what the graphs look like. So start on this first one. Just add 3x to both sides. You can do this problem with me. Okay, the second one is kind of a mean, goofy question, right? It's pretty hard because it's got a fraction in it, and we got to get y alone, so at some point we got to deal with that fraction. I think we've talked about this in here before, where a good trick is, if you don't like fractions can be kind of tough, is you can look at this and say, hey, this is 1 divided by 3, and so if I want to get rid of that divide 3, the fraction bar means divide, I can take everything times 3, and then magically it won't have a fraction in it anymore. So all of it times 3 would give us 3x. And then here, this divide 3 cancels with the times 3. So we have 1x, 1y, excuse me. And then take the other side times 3. Okay, and so we've magically turned it into an equation that does not have a fraction in it anymore. Still a little bit of work to do to get y alone. So minus 3x's. Negative 1y equals 3 minus 3x. Divide now to get rid of that times negative 1, and that's just going to flip the signs. So we have minus 3 plus 3x. Okay, so at this point, we could go to Desmos and graph them, but in theory, if we flip back and look at our list of what one solution, no solution, infinite solution, we should be able to see these have the same slope, but different y-intercepts. So this is going to be the parallel lines case, which is no solution. So in theory, we don't even need to graph it. All right, I'm just going to quickly sketch this just so we're all on the same page and can kind of understand what's going on, but you don't have to do this in homework. So if we take that first line, it crosses at 4 and has a slope of 3 to 1. So it would look something like that, positive 3 slope. And then the second line would start at negative 3 and have that same positive 3 slope. And so we just get a pair of parallel lines that never cross, so it's no solution. Okay, and again, you don't even really need to make the graph here, because once we know that they're parallel, then we should know that it's no solution. All right, next one for you to try out. So you want to copy this system down. You're trying to figure out how many solutions it has. Hopefully this will get easy for you. Is we got to get y alone, so we're going to minus 2x. Divide by 3 to get rid of the times 3. All right, and divide both parts by 3. So we get 1/3 and minus 2/3 x. Second equation, just minus 4x, minus 4x. Now that we're here, the slopes are different. So the slopes are what in front of x. So we have minus 2/3 and minus 4. Because the slopes are different, this is going to have a solution. Right? This is going to be the one solution case. They're not parallel lines and they're not the same equation, so this is the one solution case. In homework, if it is a one solution case, actually find the solution. All right, so this would just be a review from yesterday where we can use Desmos to graph these real quick and find the one solution. So if you want to pause the video, load up Desmos, give that a shot. So hopefully you did this on your own. You can check your answer with mine. I'm going to do 1 divided by 3 minus 2/3 x. That was our first equation. Solve for y. And then the second one, y equals negative 3x, negative 3 minus 4x. Should put the y equals up here for this one. Okay, so now I got the two lines graphed, the two y equals lines, and then just use Desmos to click on that point. Negative 1 and 1 is our solution. So in homework, if it has a solution, actually find the one solution. In this case, negative 1 and positive 1. Okay, last example here for you. If you want to copy it down quick, pause the video if needed. Trying to determine how many solutions. So again, we're going to start by putting them in y equals form, right? Because in theory, we're going to be potentially graphing these. First one, hey, this one's smiley face. It's already in y equals form. Nothing to do there. Second one, minus 6x, both sides. Divide by -3 to get rid of that times -3. So we get y equals -3 plus 2x. Okay, and now if we look at these two, all right, they slightly different, but if you reverse stuff over here, hopefully we would see that these are the exact same equation. All right, so going back to that chart, you can look at that chart. Which case is that when they're the same equation? So if you go back to that chart with the 3 graphs, when you have the same equation, it is the infinite solutions case. Okay, so this one would have infinite xy pairs that the two lines share. All right, so in the book, just a quick note here, this actually drives me nuts. The book, instead of using one solution, infinite solution, no solution, they're going to have these weird words called independent, dependent, inconsistent. Right, and I do not understand this because later in the book, they'll use one solution, no solution, infinite, but for whatever reason, they want to use these fancy math words here. Here's what I think of that. We're not going to do that. Just ignore those directions and just do one solution, infinite solution, and no solution. All right, and then when it is the one solution, actually find the xy solution. The other cases, you can just write infinite or no solutions. Okay, so here's 3 to kind of quiz yourself. All right, so it's going to pop up a quiz here. Give them a shot, and then I'll go over them with you. Okay, so this just asks how many solutions. And in this one, the slopes are different. 2 and -2 are different, right? So this is actually going to have one solution. If you were to graph them, you get one line that goes uphill, one line that goes downhill, and then they would cross. So you'd have a one solution case. The second one, all right, these are already in y equals again, so that's kind of nice. And we can see that they have the same slope, but different y-intercepts. So this is parallel lines. So this is going to be the no solutions case because the two lines will never cross. Okay, last one. You have to do a little bit of work here. We need to get y alone on this. Second equation, so go minus 5x. So y is equal to 6 minus 5x. And then we could see, oh, hey, these are really the same equation. They have a minus 5x and a positive 6. So that's the infinite case. So this is the same equation. So they're going to have infinite solutions. Okay, that is all. Here's the homework. Again, if it actually has a solution, find it using Desmos, and you can ignore those directions about like dependent, independent, and inconsistent. Just use the language we used in the lesson today. All right, good luck.